Alright, welcome back. Today we have absolute value, equations, and inequalities. Now, what is absolute value? The absolute value is represented by two parallel lines with the value in between. And what it represents is the distance from zero. The distance from zero on a number line. So it needs to be positive because the distance is always positive. I cannot travel -6 feet. That's impossible. Even if I'm walking backwards, I'm still moving a positive distance. So, for instance, the absolute value of 5. Well, on the number line, from 0 to 5, the distance would be 5 units. Right? The absolute value of -6. On a number line, the distance from 0 to -6 would simply be 6 units to the left. Again, always positive. Absolute value of 0 is 0. You don't have to go anywhere. Alright, now, so when solving, this becomes a little tricky. So when I ask you, let's say, to solve the absolute value of x is equal to 5. Now, we saw above that the absolute value of 5 is 5. So we know positive 5 is an answer, but also x equals -5 would also be a solution to that equation. Because since that distance is always positive, if I were to substitute -5 into that equation, it would still come out as 5. Alright. What about this one? The absolute value of x is -2. Alright, I want you to think to yourself for a second. I'm going to pause for a minute. And is this possible? Now, based on what I said, this is impossible. Alright, because a distance cannot be negative. Therefore, those are not. There is no solution for x. Alright, so what if I give you this? 2x minus 5, the absolute value of 2x minus 5 is equal to 9. Now, I want you to pay attention over here for a second. We had positive 5 and -5. Now, the same stays true here. However, since we're not sure what the value of x is, we actually have to set up two separate equations. We're going to have 2x minus 5 is equal to 9, and 2x minus 5 is equal to -9. Because we know it equals 9, so if inside the absolute value was -9, it would actually produce the same solution. So now you must solve both equations. So add 5 to both sides. 2x is equal to 14. Divide by 2. And I'm left with x is equal to 7. Over here, add 5 to both sides. I'm left with 2x is equal to -4. Divide by 2. And x is -2. So my two solutions are x equals 7 and x equals -2. Now, you can always go back and check your solution. 2 times 7 minus 5 is 14 minus 5 is 9. It works out. 2 times -2 minus 5 is -4 minus 5, which is -9, which the absolute value of -9 would still be 9. Alright, so key part. When setting up equations, let's make sure that we're making two. One positive, one negative. Alright, now inequalities. Now absolute value inequalities are a little different. Alright, when solving absolute value inequalities, we have less than and less than or equal to. Now, when an absolute value is less than, alright, that means that it is between the positive and negative values. Because if it is between, less than and less than or equal to is always associated with our and inequalities. Alright, again, it is associated with less than because it means that it is between the positive and negative. Alright, if it's greater than or greater than and equal to, that means that it's greater than. It falls outside of the absolute value of that. Alright, so greater means it is beyond the positive and negative values. So that is associated with or. Alright, again, Less than and less than or equal to is associated with between the positive and negative values, therefore it's and. Greater than and greater than or equal to means beyond the positive and negative values, so that's why it's associated with or. Oh, went a little too far. So we're going to do two more examples here. I have the absolute value of 2x plus 7 is less than 11. All right, now, so we must check. Is it a less than or a greater than problem? It's a less than problem, therefore I'm associated with an and inequality. So I have 2x plus 7 is less than 11. All right, so we copy it just as we see, but now the other side is going to be greater than negative 11. And a common theme that we've recognized with our and problems is if you notice, the inequality sign should always be pointing the same way. If for some reason they're not, that value is not going to fall between those. All right, and then we solve just as we did in the other night's lesson. Subtract 7 from all three sides. So negative 18 is less than 2x, which is less than 4. Then divide everything by 2 to get negative 9 is less than x, which is less than 2. Now, as always, we can graph our inequality. And I'll be sure to scroll back up so you can get out all in a second. Negative 9 and 2. We're an open dot. We're greater than negative 9, so we're heading to the right. We're less than 2, so we're heading to the left. And we share everything in between. So my solution is my third graph. All right, so take a look at that. Take it in for a second. All right, now let's move on to our second example. We have the absolute value of 3x minus 2 is greater than or equal to 8. Now, if we go back up here, greater than or equal to, remember if it's greater than, it's beyond our values, therefore it's or. All right, so it's an or graph. So we have 3x minus 2 is greater than or equal to 8, or 3x minus 2. Now, we're going to use negative 8, so we have to use less than or equal to. We got to flip that sign because we want the two extreme values. So then we add 2 to each side. All right, sorry if there's a little pause in the action. So we're dealing with greater than or equal to, so it's an or equation, and we added 2 to both sides. So I have 3x greater than or equal to 10, divide by 3. Oh no, we got a fraction. It's all right. So then we go back to the other side. Add 2. 3x is less than or equal to negative 6. Divide by 3. And x is less than or equal to negative 2. So let's go ahead and graph our equation. Negative 2 is to the left. 10/3 is positive. We have a closed dot greater than or equal to heading to the right. A closed dot heading to the left. So my solution is everything greater than 10/3 or less than negative 2 would satisfy my absolute value inequality. And again, you can always check. You can go substitute your values in and check to ensure that you're correct. All right, again, these are the nuts and bolts of the lesson. I give you the easy part, and then when you come to class, we'll challenge ourselves with the more difficult examples. We'll do some applications in our group work, and then you'll have some time to answer questions and get started on your homework. So we're prepared and ready to go. All right, see you tomorrow.